Class inheritance in Python 3.7 data classes. I'm currently trying my hands on the new data class constructions introduced in Python 3.7. I am currently stuck on trying to do some inheritance of a parent class. It looks like the order of the arguments are botched by my current approach such that the bool parameter in the child class is passed before the other parameters. This is causing a type error. When I run this code, I get this type error. How do I fix this?
The way dataclasses combines attributes prevents you from being able to use attributes with defaults in a base class and then use attributes without a default, positional attributes, in a subclass. That's because the attributes are combined by starting from the bottom of the row and building up an ordered list of the attributes in first seen order. Overrides are kept in their original location. So parent starts out with name, age, ugly, where ugly has a default, and then child adds school to the end of that list, with ugly already in the list. This means you end up with name, age, ugly, school, and because school doesn't have a default, this results in an invalid argument listing for _init_. This is documented in PEP 557 data classes, under inheritance. When the data class is being created by the @dataclass decorator, it looks through all of the class's base classes in reverse row, that is, starting at object, and, for each data class that it finds, adds the fields from that base class to an ordered mapping of fields. After all of the base class fields are added, it adds its own fields to the ordered mapping. All of the generated methods will use this combined, calculated ordered mapping of fields. Because the fields are in insertion order, derived classes override base classes. And under specification, type error will be raised if a field without a default value follows a field with a default value. This is true either when this occurs in a single class, or as a result of class inheritance. You do have a few options here to avoid this issue. The first option is to use separate base classes to force fields with defaults into a later position in the row order. At all cost, avoid setting fields directly on classes that are to be used as base classes, such as parent. The following class hierarchy works. By pulling out fields into separate base classes with fields without defaults and fields with defaults, and a carefully selected inheritance order, you can produce a row that puts all fields without defaults before those with defaults. The reversed row, ignoring object, for child is Note that while parent doesn't set any new fields, it does inherit the fields from _parent default space and should not end up last in the field listing order. The above order puts _child default space last so its fields win. The data class rules are also satisfied. The classes with fields without defaults, _parent base and _child base, precede the classes with fields with defaults, _parent default space and _child default space. The result is parent and child classes with the same field older, while child is still a subclass of parent. And so you can create instances of both classes. Another option is to only use fields with defaults. You can still make an error to not supply a school value by raising one in underscore post underscore init underscore. But this does alter the field order. School ends up after ugly. And a type int checker will complain about underscore no underscore default not being a string. You can also use the its project, which was the project that inspired data classes. It uses a different inheritance merging strategy. It pulls overridden fields in a subclass to the end of the fields list. So, name, age, ugly, in the parent class becomes name, age, school, ugly, in the child class. By overriding the field with a default, it allows the override without needing to do a row dance. It supports defining fields without type hints, but let's stick to the supported type hinting mode by setting auto underscore attributes equals true.
You can use attributes with defaults in parent classes if you exclude them from the init function. If you need the possibility to override the default at init, extend the code with the answer of Praveen Kulkarni. Or even
Note that with Python 3.10, it is now possible to do it natively with dataclasses. Dataclasses 3.10 added the kw_only attribute, similar to attrs. It allows you to specify which fields are keyword_only, thus will be set at the end of the init, not causing an inheritance problem. Taking directly from Eric Smith's blog post on the subject. There are two reasons people were asking for this feature when a data class has many fields. Specifying them by position can become unreadable. It also requires that for backward compatibility, all new fields are added to the end of the data class. This isn't always desirable. When a data class inherits from another data class, and the base class has fields with default values, then all of the fields in the derived class must also have defaults. What follows is the simplest way to do it with this new argument, but there are multiple ways you can use it to use inheritance with default values in the parent class. Take a look at the blog post linked above for a more thorough explanation of kw_only. Cheers. P.S. As it is fairly new, note that your IDE might still raise a possible error, but it works at runtime.
The approach below deals with this problem while using pure Python data classes and without much boilerplate code. The ugly column dataclasses.init bool serves as a pseudo field just to help us do initialization and will be lost once the instance is created. While _ugly column bool equals field init equals false is an instance member which will not be initialized by _init_ method but can be alternatively initialized using _post_init_ method. You can find more here. Note that this makes field ugly mandatory. To make it optional, you can define a class method on the parent that includes ugly as an optional parameter. Now you can use the create ... class method as a factory method for creating parent/child classes with a default value for ugly. Note you must use named parameters for this approach to work.